All right, good morning. This should be a pretty simple note sheet here. We're going to talk about arc length, and we talked about this a little bit um, last week, but now we're going to sort of talk about it in terms of radians, which is actually going to be kind of cool because we can. It actually makes the formula a little bit easier, and so if we recall, I think it was from the 7B notes when we talked about arc length. Um, the formula given to us was the length of an arc was equal to our degrees, our angle in degrees over 360 times times the circumference. Okay, so the circumference formula is 2 pi r. Okay, so n degrees over 360 times 2 pi r. Now I want to rearrange this formula. I'm going to rearrange it in 2 steps. Okay. First thing I'm going to do to rearrange this formula here is I'm going to take this 2 pi and put it with the n. Okay, and it really doesn't matter. It's all multiplication and division, so order of operations, we can kind of move some stuff around and still keep the expression the way it should be. Okay, so this is going to go to n times 2 pi over 360 times radius. Okay, so really, everything that's being multiplied in the numerator is n, 2 pi, and radius, and everything that's being divided is 360. Okay. Now, next thing I'm going to do is I'm going to take the 2 over 360 and reduce that down. So instead of 2 pi over 360, what that reduces down to is 1 pi over 180. Okay, so 2 over 360, reduce that as a fraction, becomes 1 pi over 180. So that's what our formula for the length of an arc is going to be. After we take the original one, we just move some stuff around. Okay, nothing's really changed. We kind of just sort of changed the way it looks. So the formula for the length of an arc, okay, and this is still with degrees. Okay, we're going to have n degrees times pi over 180 times r. Okay, so n degrees times pi divided by 180 times r is the formula for the length of an arc. Okay, so we learned this on the 7B notes, and this just sort of changes around. Here we move the 2 pi over here with the n, and then we, convert the pi over 360 to 2 pi over 360, excuse me, to 1 pi over 180. All right. Now, I want to come off to the side real quick, and if you want to write this on your notes, you can. If not, I'm just going to sort of go off to the side here. We know that pi radians is equal to 180 degrees. Okay. So pi radians is equal to 180 degrees. Now, if we want to find out what 1 degree is, okay, we divide by 180. Okay, so 180 divided by 180. So what happens here, ladies and gentlemen, is 1 degree is equal to pi over 180 radians. Okay, 1 degree is pi over 180 radians, and it's a really low decimal. And we looked at that back when we did the 7B notes, I believe. Okay, so 1 degree is equal to pi over 180 radians. Okay, so coming down here, let's say we wanted to find out what 50 degrees was in terms of radians. Well, 50 degrees in terms of radians. So if 1 degree is 1 pi over 180 radians, then 50 degrees is equal to 50 pi over 180 radians. Okay, you just multiply both things by 50. So long story short, to convert radians into degrees, or excuse me, degrees into radians. All right, so if you want to convert degrees into radians, and I'm just putting this down here because I have space. Okay, so you take however many degrees you have, and you times it by 180 over pi, or check that, sorry. However many degrees you have, you multiply that by pi over 180, okay? And that convert your angle into radians. Okay? Because again, there's 3.14 radians and 180 degrees. So going, what you probably learned in science class way back in the day, we want to convert degrees to radians. So n degrees, and you got to convert, pi radians to 180 degrees because that's your formula, right? Your degrees cancel out. So n times pi over 180 gives you your number of radians. Okay. So what happens here is in this formula, okay, for the length of an arc, okay, the length of an arc is going to we find it by doing the degrees of the arc, okay, times pi over 180 times r. Now, in this formula built in, okay, we're taking our degrees and we're multiplying that by pi and dividing it by 180. Okay, that's sort of just within the formula right there. Okay, well, look, when we take the degrees and we multiply by pi over 180, what we're really doing is changing it to radians. Okay, and so now what happens is, okay, convert the denominator of fraction into radians rather than degrees. We're going to forego that, okay? So what happens is the numerator times pi over 180, cross this out here. All right, so our n times pi over 180 gives us our number of radians. Okay, and now we're still multiplying our number of radians by our radius to get the length of our arc. Okay. So I'm just trying to erase some of this stuff here. So the length of our arc, as we said, going back one more time. All right, the formula sort of rewrites to n times pi over 180 times r. Okay, n times pi over 180 times r. Well, when we take our degrees and times it by pi over 180, that right there in those brackets converts it to radians. Okay, so our number of radians times our radius also gives us our arc length. Okay, now our radians, we're going to put it, we're going to use the variable theta for that, kind of like what we did with trig. Okay, so now the length of an arc of a circle in terms of radians, so the length is going to equal theta, which is our number of radians, times the radius. Okay, so if they give us an angle in radians, we don't need to go back and convert it to degrees in order to find an arc length. All we got to do is take the number of radians and times it by the radius. Okay, it's a very, very, very simple thing. Okay, if we wanted to rearrange this, okay, and get our central angle measure in terms of radians, what it would just be arc length divided by the radius. Arc length divided by the radius will give us our number of radians of our central angle. Okay. We'll talk about that more when we get into class. Just want to make sure we kind of have our notes down here. So real simple, if they give us a central angle in terms of radians, which they give us here, 3 pi over 2 radians. All right, all we got to do is multiply the radians times the radius to get the arc length. Okay, so the length of the arc is going to be 3 pi over 2 times our radius, which is 12. Okay. So 3 times pi times 12 is 36 pi over 2. Okay, so 18 times 3.14 is going to be the length of our arc. Very simple. Okay, so radians times the radius, okay, gives us the length of our arc. It's the same formula, ladies and gentlemen, as n times pi over 180 times r, or going back to even here n over 360 times 2 pi r. It's the same formula, okay? But when they give it to us in radians, ladies and gentlemen, when they give it to us in radians, the radian is all this done already, okay? All this n over 360 times 2 pi is already done if they give us the angle in radians rather than degrees, okay? So that's that. We do 18 pi. I don't have today's stuff ready yet. unless you're looking for. Okay. And our thing will be 56.52 centimeters. Okay. And that'll be that. And thank you. And you have a terrific day. You can go ahead and work the rest of these problems out on the back of D. Thank you.